what you're doing at all. You're thinking about drinking that again, aren't you? Huh? What are you looking at? What? Really? Oh? Well, I'm about to start the live stream. Got another minute or so, something like that. You just want to be pet for the last minute? All right. You can be pet and you can chew on my fingers, but you cannot drink out of that. No, ow! You cannot do that. No. It's always the longest minute. This last minute before 2 hours UTC lasts about an hour. What are you looking at out there? Looking out the window. What are you looking at? Oh, there was some kind of little sound there. All right, we're almost ready to go. Everybody's getting a preview of the pre-show. No, you cannot drink out of that. There we go. Hey, well, welcome everybody to Astronomy Daily Live. We're just sitting here shooting the breeze. She was talking and talking and talking. She decided to come up here and she's just looking around and talking and all of that. So it's like, well, I'll start a little bit early and you can see a little bit of what this research astronomer has to contend with on a daily basis. You know how important these fingers are, and I let you chew them. What do you think about that? All right, well, hope everybody's doing well out there in the universe and the world. People are popping into the chat already. Uncle Bill, hey, nice to see you. Thanks for the help over on the Discord today. We'll see, what happens there. So, yeah. There was a storm that sort of rolled through here. I don't know. It's been over an hour and a half, something like that, and it sort of rolled through. It was throwing a lot of lightning and all of that. So it's like, okay, gonna shut down. And then there was this other wave that was coming off of the Mogollon Rim, which is to my northeast. The storms, they roll off of that thing, just blast us. And so there was a wave of that coming in that was, the way that it was moving in terms of velocity and direction, it would have hit us right about now. But it sort of petered out after the sun started going down a little bit more. So, yeah, I think we are in the clear in terms of storms, which means hopefully, no power outages here in the next hour or so, because we are here gathered together with our consumables of choice. I've got the hydrogen hydroxide again, a very nice calming molecule. So, all right, well, cool. So Uncle Bill, great to have you there. Uncle Bill, she was just up here and we were having this really great conversation. So it's like, yeah, we're going to start early and you can just sort of see the antics behind the scenes. It's a madhouse. It's an absolute madhouse. So anyways, so hey, Andy, nice to see you there. Tom, great to have you back in the chat. Cheers. So yeah, except for this little storm that blew through, it's been a nice scorching day, and I absolutely love it. I It's hot and dry is just my it's it's just like my perfect place. Absolutely perfect. Don't feel cold. Definitely don't feel cold. And it's dry. So and even now, the humidity is high. Shh. Hey, look who just popped in. Atta, hey, how
I
are
made
you?
it. I had engine trouble.
Engine trouble. Well,
Yeah.
you got to make sure you got to let the Navicomputer, you know, make sure that the course is properly computed, because you don't want to be running in, through a supernova or a black hole or something.
That's right. This is the
So
closest
yeah,
thing to a black hole I'm going to get.
there you go. All right, well, cheers. So yeah, hope everybody's doing well. Things are good here. Things
Hi, Andy.
just going along, going along. The AAS, um, the American Astronomical Society, they now have a YouTube channel, which I subscribe to, and just today they put out a video about a service that they offer that is really kind of cool, really kind of cool, and so I think that's just sort of what I want to do today, is just sort of explore that a little bit. Just think about some things. I'll show you the interface here in a minute. I posted a link to it over on my Discord server, and there's a link to that below in the description, somewhere down here. You'll also see other various links to things, including a Patreon page to support my research, um, and which has absolutely nothing to do with this live stream whatsoever. This live stream is FUN. That's all it is. The research is FUN and one of those four-letter words, WORK. So I hate to say, uh, you know, I just don't like that kind of word at all. But it must be done, because if you don't, you won't have any fun at all. So so they go together. So if you'd like to support that, you can go over to my Patreon page there. You can just go over to Cosmic Lettuce. I think you should be able to find it that way. So, all right, well, cool. Let's see what else is going on in the chat, if anything. Over on my Teespring thing, I do have a new promotion code. It's ADL723, because today, right now, it is 2:07 UTC on the 23rd of July 2019. So welcome, everybody. Hope everybody had a great spin. Hopefully it wasn't too dizzying or anything. It was a great launch. India launched its probe to the south pole of the moon, and I wish I would have known about this sooner, because I would have liked to find out exactly what they plan on doing, provided that they can actually land. So they've got like a 54-day trip. They launched, they get into orbit around the Earth, and then at very specific times in the orbit, they'll give themselves a little boost. And so, each time they'll sort of fling around and go out a little bit more, a little bit more, a little bit more, until they cross that point where the gravity of the moon is actually stronger than the gravity of the Earth. And I think they give themselves a little bit of help there too, to probably get in the right orbit. But once the moon has got you, it's got you. The only way out is to boost yourself out. So, so yeah, I think it's like a 54-day thing. I have absolutely no idea what kind of instrumentation is on there. I'd be curious. And the Indians are going to share that kind of information. Oh, and I did actually read something. I forget exactly where I read this, but I just read it today. This is going back to a conversation that we've had a few times about China cooperating with the United States, or like I point out, is it the other way around? And I read something today. Oh man, yeah, this is definitely a red alert. um, it is the policy of the United States to not share anything with China. So whether it's the policy of China not to share anything with us, I have absolutely no idea.
Well, if I were Chinese, that would be my policy toward the U.S. if I knew their policy was not to share anything with me.
Yeah,
come on.
It is so sad. It is so sad, and it is so small-minded. It's like, come on, let's. It's so much easier to work together, and there's so many more of them. They can do so much more than we can.
You better believe it. And they are doing more than we're doing.
Yeah, and that's exactly how it should be. It's like they have the numbers, so they are going to advance much faster than we. Absolutely, they're going to catch up to us, and we're going to eat their dust.
And space exploration, we're not talking about weapons of war here, or hardcore. Space exploration is for the planet. It's not for the United States, right, or for China or for Russia.
I think this is the basic logic, is that if China, our enemy, right, shared, if we shared our technology with them, then they would at least be able to very, very intelligently infer what kind of missiles we have aimed at them.
They're not going to fight us. And we are so in debt to them. They're like, running a juice racket here. They're not going to kill the people that are $19 trillion in debt to them.
No.
And buy all their products with
money
we're just borrow from them.
We are just going to be absorbed, and that's all. We will continue just like this. It'll be exact. Yeah. So
I don't get it. If we don't get together as a planet, as far as space exploration goes, we don't deserve to be out there.
Yeah, absolutely.
We can't get our act together here. How are we going to get it together outside the planet? We're not. I've got my fingers crossed that we will.
Yeah, and I see it as a race. I really, really do. I see it as a race now, and it doesn't. Not all. These kinds of ideas don't have to dawn on all of us, right? It just has to dawn on some percentage, right? Some percentage is going to tip things, and right now it's just a race.
This is a cool question. It says, why go to space in the first place? I'd like to answer that. For the same reason Sir Edmund Hillary climbed Mount Everest, because it's there. I'm curious about it. I want to find out. I just want to know. You can give your answer.
Yeah, that's exactly it. It's just a curiosity, and we are just insatiably curious. That is the
Yeah.
situation we're in. We are so absolutely confused, and we're frustrated because we don't want to be as confused as we are. We want to try to understand things, and so we look out into space, and we can get a sort of a good idea, but going to these places either with probes or with ourselves, and there is merit to both. Yeah, it's just a curiosity thing, and that is at least one of the three legs of science. You've got to be curious, or you're not going to be able to do science at all. So, and welcome, Vago. Yes.
By the way, hi.
By the way, hi. Yeah, you lead with that kind of a question. Fact of the matter is, Vago, there is more than enough to go around. Okay, we have uh, we have so much wealth that it doesn't matter, right? So we have access to anything. It's all that we need is the will to do it. So we can solve all the problems on this planet and explore like crazy in space simultaneously. We don't have to choose. It's ridiculous. There is no scarcity. It
The
doesn't
problem
exist.
is distribution. It's not stuff.
Yep, it's distribution, and that is a political problem, right? That has nothing to do with can can we get this from here to here? That's easy, right? FedEx does that every single day, right? UPS, the mail. So getting things from point A to point B, yeah, that's not a problem at all. So, and you know, there is so much here on this earth, and if we run out, we just have to go out a little bit into space, and there are mountain-sized objects out there that aren't doing anybody else any good. They are ours for the taking. We just have to figure out how exactly to do it. But it's not a matter of if, it's a matter of when. So it just takes some will. Well, to me, Vago, and
Art alert.
Ert alert. Hey there, Ert. Hey, Ron. How are you?
You love to do that, don't you, Ron?
Yeah.
You do. I know you do.
You make everybody jump about 5 feet in the air. Anyway, so
how's everyone doing?
Good. We have a new person in the chat that is asking some questions, and I just want to preface what I'm going to say with this. This live stream is not about me giving answers. I don't do that. What I do is I give questions. So I don't really like Q&A all that much. What I like to do here is just explore a little bit, follow my nose and take you all with me. I've been doing this for years and years and years. Just recently on YouTube, though, past year and a half or so, and I try to do it every single day because that's what I've been doing for all this time too. So, all right. So yeah, science to me is a tool. That's all it is. It's just a tool. It's it can become very, very dogmatic, and there are high priests now, right? When somebody wants an answer, they go to the high priests, the modern high priests, who are the scientists, and the scientists give us their response, which is some kind of an answer, right? And a lot of them are very, very sure of themselves, and there is absolutely no surety whatsoever. But science is just a tool, and to me, it sort of got three main legs. One is curiosity, which is why we should go out to space, because it is screaming at us, right? Come on, hurry, you can do it, right? But there are two other legs too. One is skepticism. Now, not cynicism, right? I'm talking about skepticism, where when you're presented with something, it's sort of like, what's this all about, right? Be extremely skeptical about anything. It doesn't matter what it is. Even if you're sure, right? You got to have that little bit of doubt, that little bit of skepticism, right? I mean, I am pretty sure that this pen is going to go this way when I let go. But you never really know for sure, right? Because I've got to be a skeptic. Claiming to be a scientist, I've got to be skeptical. Everything.
And I don't know that you should take the first answer you get either the first time. Like when you look at medical situations, you look at your, oh, this is what's wrong with you. You got this problem. Oh, but you could also have this problem, and they give you like 4 or 5 different options of, and one of them is always death. You can die from this, whatever it is.
Absolutely. Yeah.
And you don't really get a clear-cut answer of what you're looking for. So
it's going to happen sooner or later anyway.
Yeah, right. Well, I'm suffering with a stomach pain right now. It comes and goes, and it feels like sharp pain. And then I'm looking at the appendicitis, because I do have my appendix, and so it could be that, but I'm hoping not. In any case, it just they started out with, oh, it could be gas. Which I could accept that. It could be gas, and then. It could be, just stomach cramps or whatever. If you're a woman, then it could be a woman thing, whatever. And
so, who knows? Who knows?
So, you just don't take the first answer is what I was trying to get at.
Very, very, very true. Very true.
I got hurt going.
So, right. So, be skeptical. Number 3, that third leg is open-mindedness. So you've got to balance this skepticism with being completely open to the possibilities. You've got to hold both of those things in your hand. In fact, all 3 of those things. You have to juggle these things a little bit. And to be a good scientist is to be the holder of those 3 things simultaneously. And it's hard. It's hard. And I think there is a lot of dogma in science. There always has been, always, and there always probably will be. So and science will evolve too. The best kind of tool is the kind of tool that actually evolves with you. So all right, well, cool. So what I wanted to do
now we got all that out of the way.
Now that we got all that out of the way, I wanted to go explore this this site that the AAS set up and was talking about. It's called the Astronomy Image Explorer, and I'm going to have to watch the video that the American Astronomical Society posted on this again to rehear a lot of the information that he gave, because he he packed a lot in to a very, very short
On the
amount of
YouTube
time.
video you're talking about, American
Yeah,
Astronomy. Okay.
yeah. I can probably find a link to that YouTube channel. Well, no, I don't think I can. Anyway, yeah, just look for, I think it's, we are here now. So yeah, I think if you just look for AAS, and maybe put American Astronomical Society in there too, in the YouTube search, and you should be able to find it that way, I would think. So I guess what this is this is a, well, let's see, there's an FAQ. Okay, that's not too helpful. What it is, it's sort of a searchable image and figure database. They've apparently extracted all the images and all the figures from all the papers back to 1995. At least all the ones that they own. So, they own the Astrophysical Journal, the Astronomical Journal, the Astrophysical Journal Supplement, blah, 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 all these guys here. I don't know if you can see that or not. Zoom in a little bit. And actually, the AAS just recently acquired Sky and Telescope magazine too.
Yeah.
So haven't heard anything about that yet. I'm eagerly awaiting what they're going to be doing. I was sort of hoping that they'd have that, here in this list, but it's not here yet.
I'm sort of hoping they eventually send me my subscription premiums, but I'm losing the faith after 6 months.
Yes,
and calling them once a month.
I'm the one that didn't get it yet. Okay,
I would be too, and
happen.
yeah, I don't know. Sadly, I have to agree with you. Yeah, I don't really see that happening. I think you and probably many others got lost in the shuffle. Literally the shuffle.
Well, they should be able to find out that you paid for it already, and it should be just a backtrack.
You would think, but we're talking probably about some kind of database that is probably going to have to be merged with something else, and when you merge databases, sometimes information doesn't get passed along because of a mistake in the programming or whatever, and it's sort of assumed that it all worked because it looks okay, but they don't look at it carefully enough, and all of a sudden you're lost. Anyway, so yeah, this looked kind of interesting, and I thought that we could just, I don't know, look for some objects. I guess we could look for star names or planets or asteroids or whatever. And I guess you can search in the abstract and the title and the captions, or you can search by author. Now, the interesting thing is that when I typed in my last name here for the author search, nothing came up. And I'm not exactly sure why, except I'm thinking about it now. I think out of all these publications, I think that I only wrote one paper for one of these, and that was the Astronomical Journal, and that was in 1993. So it's possible that that's why it's not coming up. But I'm author and co-author on I think like 23 publications, as I recall. One of these days we'll do that search, and I'll take you down some memory lane a little bit. In the meantime,
1993, I was delivering pizza then.
1993, I was that paper is about photometry of white dwarf stars that I was doing up at the 61 inch on Mount Bigelow, just north of Tucson. Good times, good times. So I don't know. Let's should we search for? I don't know. Let's search for a planet first. Let's do
Jupiter.
an obscure one. Let's do Neptune.
Oh.
No one pays enough attention to Neptune. It's a pretty amazing place. Very, very active. Anyway, let's do a search here and see what this does. I don't know what it's going to show up here.
The one moon of Neptune has geysers on it. Is it? Right?
Yeah, I don't know. I think you're talking about Triton.
Okay.
And I don't think that there's anything conclusive about that. I
thought they saw some kind of activity happening.
Yeah, on Triton,
yeah.
I'm not sure. I know that there are two other moons, one of Saturn, Enceladus. That one has some kind of activity like that. It looks like geysers or something. And then Europa around Jupiter there is a little bit of evidence there that it might. I haven't heard of Triton. I don't know if anybody in the chat has heard anything about that. I don't think that we'd be able to see that from here. So unless Voyager saw it, which I don't think it did.
Well, I wonder where I got that information. I remember hearing something about it though, and that's
I got you. Yeah.
I brought it up, and
yeah.
So you were talking about nobody pays attention to Neptune.
Nobody pays any attention to Neptune. So, as you can see, this is just a big list of figures. In this case, various drawings and distributions and whatnot that at least are in papers that should be talking about Neptune. So here's sort of more like an image. Should we? So if you click on it, you'll see that you see this enlarged view. But then it went away. You can view the article, and I've yet to find one that I couldn't access, but this might be the first one. Yeah, it's got a paywall. But, okay, so this is talking about sub-Neptune. So these are exoplanets that are well, at least they think, Neptune-like. Let's see if we can find it over at Archive just really quick. Like sometimes we can. Look for the title over here. Dun, dun, dun. Search. Sometimes you get lucky. Oh, there it is. Isn't that the same one? HD 3167. Yeah. Right.
arxiv.org.
Yes.
Archive.
Okay.
Yeah, the X is a Greek letter chi, so you sort of pronounce that with a ch sound. So it's archive.org. It's really nerdy. It's seriously nerdy.
I thought so, Paige. Yeah.
Is
Uh-oh.
Page Master making an observation?
Yeah.
Nothing came up.
Oh, sweet. Okay.
Geysers on Triton. Yeah.
Wow. I hadn't heard about that.
Yeah.
Wow.
Okay, so I did have it right. I just
Yeah,
didn't
very
know
cool.
the name. I didn't know the name.
Yeah, and I had
That's
absolutely no idea.
That's the bad thing about memory loss is you
Yeah.
remember half of what you know and forget the other half. So
You're just a baby. You don't know memory loss yet.
actually, yeah, I do. Yeah, I don't remember names.
Well,
very
anyway,
well.
well, cool. So yeah, I did not know that Voyager 2 discovered ice geysers on Triton. I did not know that. I'm gonna have to look into that a little bit. That's never talked about when they're talking about perhaps finding life on these moons. They never talk about Triton. So, wow. I don't know. See, you're experiencing the skepticism part, but you're also experiencing, the open-minded. I'm going to go find out.
At least I was on the right track, anyway.
Yeah. Well, Triton is the only Neptunian moon that you can see from Earth. You can definitely see it. I forget. It's really faint, of course. You need a pretty sizable scope to see it. Probably, with your own eyes, you'd probably need at least like a 16-inch or something.
Oh, wow.
But, you could use a much smaller scope, do a little bit of a long exposure, and it would pop out in a couple seconds. So yeah, I mean, it's not incredibly faint. It's just faint enough that you can't really see it with your own eyes unless you got a big scope. So, all right, well, yeah, I don't know exactly why, unless this talks about Neptune specifically. Well, I guess it sort of does. Okay. This was talking about a figure too, so okay. Well, there's the image in the paper that we were looking for. Pairwise posterior distributions of whatever these variables are. Not quite sure what those are, but okay. Yeah. I would say nothing too incredibly exciting there. Showing a lot of what looks like some distribution plots or something. Kind of hard to tell. Test planet D, test planet B.
X.org, no, ARX, Wikipedia. Huh.
ARXIV. Hadley cell circulation width. What does that have to do with Neptune? That's a weird one. Oh, look at that. It's actually mentioning all the planets here. Huh. What is that all about? Analytical estimation of the widths of Hadley cells in the solar system. What the heck is a Hadley cell? Does anybody know what that is?
No, I don't know what that is.
Hadley cell circulation. And they're talking about it with all the planets. You see, here's Neptune way out here. That's why this paper is here, because they actually mentioned Neptune in it. That's pretty crazy.
Hadley cell, is that a gravitational?
I don't know. I've never heard of it. Let's see if we can find the article at least. I don't know. It might be through a paywall. Yeah, we might get stuck with this one. I don't think this is going to be coming through archive. Let's just do a Google of it, and we'll look and see if there's a. I'll put that in quotes, so it just searches for that string. Yeah, it doesn't look like we're going to be able to grab it here. These, I think, are both behind the same exact paywall. Yeah. Let's try it just in case. No. Okay, so yeah, we're not going to know. We're not going to be able to see within this paper except for this figures, and well, this one. There's a few other ones it looks like, but yeah, it's not going to help us much.
I don't even know what a Hadley cell is yet.
Yeah, I don't know. Should we?
Let's see.
We can look that up really quick.
Hadley.
Yeah, Hadley cell.
Just like it sounds. Hadley, not Handley.
Yeah, I got it. Hadley.
Yeah, sorry about that.
Hadley.
Well, Cosmic doesn't. He spelled it Handley.
Yeah, well. Okay, so global scale, tropical atmospheric circulation.
Ah. So, yeah, when you mentioned all planets have one, well, that would make sense.
Okay, yeah.
Well, every one of our planets have some kind of atmosphere. Not much of one, and some like on.
Well, every single planet for sure has an atmosphere. None of the moons do.
Okay.
Or well, and that's not even actually totally true either. So some of the moons actually do, but
atmospheric circulation, basically.
Yeah, it's the rotating cells that are going from.
Master, of course, has this nailed. If you look at the chat.
Good.
So then, what you'd be talking about is like when Jupiter cloud bands and the big red. That would be a Hadley cell.
That would be some form of a Hadley cell, I would say.
Interesting.
Yep. Yeah, very cool. Right. Yeah, so here you're just showing it, for different planets.
Yeah, that's the same one I got.
Yeah.
Funny, cool. I couldn't find that page. I don't get it anyway.
So I guess this is the elevation of some tropopods. I don't know which one. Yeah, it's kind of hard to read this, but all right. Well, that is extremely nerdy. Let's keep looking here. And I mean, we can move on if you want to. We don't have to. Okay, so here's some 233 gigahertz images, I guess you'd say. An AU scale, astronomical unit scale. Let's see how much access we have to this one. Look at those nasty people. All right, we're going to try. Let's see, we can get rid of all of these. Yeah, we can get rid of that one. Okay, this one. Let's try. We must try. This could be over at archive. Let's try it. All right. Yeah. This could be over at archive. Title. Search. Bamaroo. We got it. TW Hydra TW Hydra. That's it. So somewhere in here, Neptune is mentioned, right? I think that's the whole idea.
Okay.
Looks like a bunch of Japanese scientists. There's a couple here in the UK. Here's one in the UK, at least. Here's another one. Cool. So that's a nice collaboration there. Very cool. All over the place in Japan. Look at that. Wow. That is sweet. It's nice to see. Let's see here. I'm just sort of keen on that image. Okay. White ellipse at the bottom left corner. Okay, yeah, so this is sort of the resolving power. So that is the overall view, but they're noticing that there's a little bright little blob right there. So, well, okay.
Do you notice PageMaster's putting a bunch of info on Hadley cells up on the Discord server?
Oh, good. Thank you,
Link to
PageMaster. Yeah, we appreciate that. I know that's a lot of effort, so thanks. All right, well, cool. So here they kind of got rid of a little bit of the signal and left a little bit of the little blob there. So that's kind of cool. So what else we got? Oh,
That ain't
yeah.
the one.
Yeah.
That looks good, but that ain't the one.
Using some wild imagination here a little bit. That's okay. We've got to hope. Okay, yes. Well, this is looking at a different frequency, which means, of course, a different wavelength. These are microwaves. Or no. These are, well, very, very microwaves. Yeah, they're gigahertz. So wow, that's way out there. So here they're looking at it at 325 gigahertz, and I would sort of say, I don't really know if you're seeing anything there or not. You know, they try to remove a lot of this sort of glare here, but you know, are you really seeing anything? Yeah, that's hard to tell. But at, what was this one? 233 gigahertz. Oh, yeah, there's definitely something there. So, cool. Kind of interesting. Don't know what that has to do with Neptune.
Except for the Hadley cell.
Neptune, Tune. Excess emission can be explained by a dust clump accumulated on a small elongated vortex or a massive circumplanetary disk around a Neptune mass forming planet. Okay, so they're thinking that this is actually like a Neptune-sized object already. Wow. I guess that's how I would interpret that. Yeah. A lower mass planet like Neptune. Yeah. All right. Yeah, it's kind of interesting what these searches result in sometimes. Lots of figures. I guess this is, they're sort of advertising this as a place, you know, if you have a presentation that you want to give, or you know, if you have any kind of like a slideshow or anything that you want to show off, or if you want to publish anything, you can sort of look here for the figures that you might want. So, you know, is this useful to us? I don't know. Let's search for NGC 3256 and see if we can see anything interesting. This has sort of been our adopted object of the day the past couple of days. So let's see. I'm seeing some spectra. Yes, you know, some blobby things. Kind of hard to tell exactly. So yeah, you know, how useful is this to us? Oh, I don't know. Probably not incredibly useful. You know, if you're into tables and charts and all of that, yeah, okay. But yeah, that's probably a bit much for this live stream, because, you know, it would take me some time to figure it all out. So yeah, that's, this live stream is more about just sort of going, wow, that's very, very cool. So yeah, not seeing much here. There are some pictures, and I think you can probably search that way. Let's see, can you just look for images? I think you can. Yeah, see, they have images with astrometry. They have some videos. Let's look at the videos. We can search for videos and then come in here with 3256. I don't think, oh, wow. There are some videos, it looks like. Fascinating. So video showing samples from our density run. So yeah, that's some kind of model, it looks like. So they're showing off that. I don't see how to, okay, here's the video. Let's see if we can, it's probably going to be an ad. Oh, maybe not. Okay, well, it's playing, so for what it's worth, we can sort of see. I'm not quite sure what they're showing here exactly. Looks like some kind of a color on the vertical, and some kind of magnitude on the horizontal. So, but yeah, I'm not quite sure what that's showing. Slight variations there, but yeah. So yeah, I don't know if this is worth keeping around as a resource. It might be. I'm going to try to remember it at least, because they are, you know, I guess there are some relevant things here. So yeah, we'll see. We'll see how that goes. Let's see. So they're talking about an MPEG animation. I'm probably not going to want to grab that. So, all right, well, cool. Let's try something else. What do you think? We could do. Let's do Supernova 1991T. That supernova is in my head because it's a supernova that I actually saw. Okay, I think it's still doing. Oh no, it's not. So, all right, well, just 8 images.
Got it.
You got it?
Finally got it.
Good.
Only took me a few guesses. But it's the
So
same site. Okay.
it's the same what?
It's the same site you're looking at.
Oh, good, good, good.
I just wanted
Yeah.
to try to track it down and find it so I can look at it later.
Oh, I apologize. Yeah. Let me. Now that you've done that, I'm going to post it over. I'm going to post it over in the chat.
Yeah. And I did a search on Google searches, Astronomy Image Explorer, and then bam, it came up first thing.
Yeah. Good. 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 Good.
So just a clue in case anyone is having that trouble. Just type in the generic name of the page, and pretty much it'll give you
Yeah.
something. Of course, I went through a dozen pages before I finally found it. But that's half the
Well,
fun, though. I did
you
find some cool. I found some cool pages, though.
you are learning well, because
Yeah.
that's exactly you know, in uh, you know, like, instead of being frustrated and being like, where's the thing I'm actually looking for, you're sort of like, wow,
Yeah.
I'm going to look
Yep.
at all of this eventually.
And it's funny. I mean, of course, we stopped at Hadley's Hill and looked up that and got that information, which we kind of assumed what that was before we even looked it up. I think.
Yeah. Well.
So when you mentioned it, it's on every planet. That kind of made me think atmosphere.
Yeah. 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 Cool.
Something that every planet has
Yep.
a little something of.
A little of it, at least.
Yeah.
All right. Well, this paper looks like we have access to.
That's
So
fine.
let's
Now
see.
I got it. Now I got it saved, and I'll come back to that. Now watch what you're doing.
Yeah. Cool. I'm just following my nose.
Thanks for sharing that page. So that's pretty cool.
Yeah. Well, like I said, I don't think it's really for us here. There's that I think is a great resource. If you're trying to make a presentation, or if you're trying to write a paper and you want to include a figure, from somebody else. Yeah, I think it's absolutely great.
For information only.
Yeah, but for us here, I will definitely keep it in mind, but it's not going to be the first thing I jump to.
Now the object of the day, you're talking about a nebula.
Well, the object of the day that we were focusing on for a little while was NGC 3263.
Oh, I was close.
Yeah, which is part of some kind of an interacting cluster.
That's right.
And I guess the main galaxy there was NGC 3256. So we sort of switched over to that. But anyway, so here's 1991T, and yeah, it's just it's mentioned as I thought that it probably would. It looks like it might be in Figure 6, so let's look for Figure 6. This is so these are some spectra. This is Figure 4. I know I got stalled at Figure 4, but that's okay. I'm trying to zoom in. Oh, there we go. Oh, zoomed in a lot. So 1991T is the orange one here. So sort of have to look around. There it is. So that's just a spectrum. It looks like it's a visible light spectrum. Yeah, it's going from about 3,000, which is pretty much into the ultraviolet, all the way out to 9,000 angstroms. So yeah, that's the visible part. They're marking a few things out here: iron, calcium, silicon. These might be sort of the rest wavelengths of where they should be if they were at rest. So yeah, it's just a spectrum.
And that is on what? On what?
This is the spectrum. Well, this orange one at least is the spectrum of supernova 1991T.
Okay.
which of course blew up. We saw it at least in 1991.
Oh, okay.
Okay, well, let's see what else is. So we definitely probably should go and see.
Well, if we saw it in 1991, when did it really happen?
You know, I don't remember exactly when that one happened. We can find out. You know,
That's actually when I started working for the pizza place too.
the 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 supernovae back then were sort of so few that they would start with A, and by the end of the year they'd usually be in double letters, so like AA, AB, AC, something like that. So I think the fact that this is a T, I want to say it was probably discovered maybe like mid-year. I don't know. Let's see if we can find out. I'll bet you PageMaster will be able to find it before I will.
Well, yeah, he's not hosting a show though. He's just a guest.
Merely a guest, yes.
No offense.
Wow, I'm not seeing it here. So there is a supernova database somewhere. Supernova database. The Open Supernova Catalog. That was it. This is kind of an interesting site too. Takes a second to load, but then I think you can. And I guess we're not getting completely off track here, but we're a little bit off track. I'm going to let this load because now I am curious. But yeah, I'm thinking it was mid-year of 91.
Okay.
Let's see how accurate I am. This thing is trying to load, so it just has to. We just have to be a little patient here. We can go back to this, and
so now who actually looks for these novas or things, anomalies happening in space, like
yeah,
there's a certain set of people, like, okay, you guys are looking for this and you're looking for this, or what is are you guys assigned a certain job? I mean, like when you're I guess if you're on a team, right, you'd be on a different type of a job. Each one would have their own job.
Well, how it's working right now, at least, is there are groups that are watching the sky continuously. Maybe not the entire sky every single night, but they're covering the sky, at least what they can see, over the course of several nights, maybe every couple of weeks or so. It sort of depends on the telescope. It depends on what they're doing, and what they do. After they've taken two images of the same piece of the sky, they can do a comparison. They can subtract the two and sort of see what things have changed.
Mm-hmm.
And so a lot of discoveries are made that way. Very, very, very soon, within the next few years, there's a telescope that is coming online. It's called the LSST. It's the Large Synoptic Survey Telescope. And this facility is its job is to find these events, random events in the sky. and that system is going to be able to look at the whole sky. I think every 3 days. I think, and they are predicting that they will be finding at least 1 million transient events every single day.
Oh my God. It's automated, I assume.
It is completely automated, but if you want to follow up on any of these things, there aren't enough telescopes on the planet
to keep up with it.
There's absolutely no way. No. And I think 1 million is probably a low estimate.
Oh,
I think it's it's probably going to be more like 10 million, or maybe even more. And I think they're talking about a petabyte of data every day.
Wow.
So that's a billion megabytes.
How are they?
A lot of hours. A lot of hours.
I mean, talk about data overload, information overload. How are they going to sort all that data out? That's like everybody was worried about the government recording all their phone calls. Even if the government did that, how could they sort it out? You know,
how would they say? But yeah.
No, it's a problem that the astronomical community has been thinking about for at least 20 years or so.
It's great to collect all the data, but data is only good if you can analyze it and understand it. And if you have much of it, you're buried in it.
Yeah, well, one of the things that has come back in earnest lately are these neural nets, these machine learning algorithms that can handle a lot of data and actually find things in there that are sort of buried. That is at least one of the techniques. But yeah, it's a mountain. I mean, it's a huge mountain. It's a huge problem. I think in terms of storing that data, that's no problem anymore. It's cheap. So petabytes a day, that's no problem anymore. That sounds like a lot. But to me, a megabyte sounds like a lot. So, but this is petabyte now. And that's just one
mechanism to analyze the data, even if it's machine assisted, which it probably is going to have to be.
It's completely automated. They have a pipeline, what's called a pipeline processor, where the data, the raw data, and all the calibration data and whatnot come in, and and all these data products are spit out. Images,
unionized,
spectra, photometry, transients, all this stuff. One facility that I think is just looking for transits is called the Zwicky Transient Facility. It's ZWICKY, I believe. Check them out. They
famous,
isn't it? Yes.
Yeah.
Famous astronomer. Yeah. Famous astronomer back in the 30s and 40s.
Oh yeah.
And I'm sort of afraid.
Back in the day.
Way ahead of the
day. Back in the day. Anyway,
time and not recognized in his lifetime.
Yeah. I am looking at the time and I'm noticing that it is 3:07 UTC. So wow, it was a fast over hour. So yeah, I think it's about time to get on out of here. My throat is dry. I wonder why that is. Don't know. There goes Anta. Anta's out of here. She's beaming up. Cheers, Anta. Thanks for coming in.
All right. See you next time.
I'm going to do exactly the same. So cheers, everybody. Peace and cheers. Live long, prosper. Have a great
And
evening.
you remember
Great
to tell
day.
a friend.
Tell a friend. Tell a friend. Tell a friend. And smash the thumbs up if you so desire. Subscribe if you haven't already. And yep, I will be back here again. As long as the storms aren't blowing me out, I will be back here again tomorrow, 2 hours UTC. And that's it. So I will see you again in a little less than 23 hours. Just one little spin of this little tiny little planet. Okay, everybody. Take care. See you later. Bye.